and a warm slope. Okay? Next, please. But now, I told you there are different inclinations. That's why there is a classification of lines by slope. For example, when the line go to the right, okay, the inclination go to the right, should be a positive slope. This number 1 corresponds to the line 1. If the inclination of the line 2 is to the left, we are talking about a negative slope. Line 2, number 2. If we have a horizontal line, okay, a flat line, obviously you don't have inclination. That's why we say this is a zero slope. And finally, when we have a vertical line, undefined slope, because you cannot find any inclination, right? Please, go to the next. Go to the next. There is another different and typical situation when you have a parallel lines and perpendicular lines. Obviously, if you in the graphic, okay, you can see two lines, but they have the same inclination. Obviously, if they have the same inclination, they have the same slope. And that is how can you recognize when you can see two different linear equations? If they have the same slope, it's because they are parallel lines. The other situation is when you have two perpendicular lines. In other words, they form 90 degrees in the intersection. This is 90 degrees. Right? What happens in that case? The multiplication of the slopes should be all the time -1. Or you can say, okay, M1 should be -1 over M2. Or M2 should be -1 over M1. Okay? So, for example, okay, now, if we continue the class, okay, for example, we have the first linear equation y equal to x plus 1 and the second linear equation y equal to x plus 3. For example, Andrea, I need to know if they are they parallel line, yes or no?
No.
Okay, will you tell me why, Andrea?
Because they have different slopes. One of them is positive and the other one is negative.
Perfect. Okay, let's continue. Let's see. Let's continue about the perpendicular lines. For example, let's see, Fernanda. Suppose you have the linear equation y equal 3x plus 1. What is the slope in this linear equation? Fernanda, you. The question is for you. What is the slope in this linear equation?
The slope is 3.
Very well, Fernanda. Congratulations. Okay, we have the line 2. I need to know what is the slope of the line 2.
The slope 2 is -1 over 3.
Very well, Fernanda. You understand it very well. Thank you. Okay, this is the last part of the class and probably the most important because according with the NCA standards, okay, we have to operate and create and use the best fit mathematical model for linear equations. For example, here we have a problem. Okay, let's see. What's the problem? In the Mojave Desert in California, the temperatures can drop quickly from day to night. Suppose the temperature drops from 100 degrees at 2 p.m. to 68 degrees at 5 a.m. in the morning. Find the average rate of change and use it to determine the temperature at 10 o'clock in the night. Okay? Let's do it. You have only 2 minutes to solve the problem. Okay, this is the solution of the problem. That's why it's so important to know what is the slope formula and how can you use the real life problems. For example, you can get it when you need to obtain an average. What kind of average is about the change in temperature over the change in time? Okay? What is the change of temperature according to the problem? Remember, we have two different temperatures, 68 degrees and 100 degrees. Okay? And remember, the temperature is dropping. That's why I start with 68 degrees minus 100 degrees. Over what? Remember, you have to maintain the correct order. What is the time when you have 68 degrees? It's 5 o'clock. What is the time when you have 100 degrees? 2 p.m. o'clock. Obviously, 68 minus 100 degrees is negative 32 degrees Fahrenheit over 15 hours. And if you divide it, you get negative 2 degrees per hour. In other words, each hour, the temperature will drop 2 degrees. Do you understand? Yes?
I have a question.
Okay.
Yeah. Is the problem why is 15 hours and not 9 hours in the denominator?
Yeah. Oh, Andrea, I think it's an interesting question. Thank you very much. Okay. Why we have 15 hours? Okay, let's see. 5 a.m. to p.m. 5, let's see, 6, 7, 8, 9, 10, 11, 12, 1, and 2. Oh, we have 9 hours. Oh, let's see what happened. Okay, let's see. Sometimes it's necessary to reread the problem. Could you go to the previous? Okay, let's read again the problem. Suppose the temperature drops from, we have to start not in 5 a.m., not 2 p.m., because remember, the temperature starts to drop when you have 100 degrees. So, if you start to count downward between 2 p.m. to 5 a.m., those are the 15 hours. That's different, okay? If we start to 2 p.m., could you go to the previous slide, please? Okay, thank you. If we start here at 2 p.m. to 5 a.m., obviously, we got that 15 hours, okay? Why? Because in that moment, the temperature start to drop of 500 degrees to 68 degrees. Those are the 15 hours. Let's see. If you think, okay, the temperature starts to drop from 100 degrees to p.m. to 68 degrees at 5 a.m. So that's why we need to start to count when the hour or the time is 2 p.m. How many hours do you have between 2 p.m. to 5 a.m.? Those are 15 hours. That's it. Okay. Okay. In this way, we can finish the class about slope and rate of change. Obviously, the last part of the class is when we practice and the student make the application of the formula with different problems, and obviously, I will give them the homework for the next day. Well,